Hi everyone, in this video we are going to continue our lectures in which we are going to learn about how to calculate or formulate moment of a force, and in here particularly we are going to discuss the scalar formulations. Okay, in the previous video we have learned what is moment, right? And in that video we talk about that there are two important components for moments to occur, right? The first one is that we have a force, right, or a set of forces, and then the second component is that there is a distance, right, from the location where we apply the force to a reference point in which we are to a reference point. Okay, and then let's investigate that in much more detail in this video lectures right here. Okay, so let's assume that we have x and y axis. Okay, so that is our x-axis and that is our y-axis, and we have a reference point O in which we are going to calculate the moment about. Okay, and then let's say that right here we have our first force, okay, which is our F1. Okay, that is our force F1. Okay, and we put a head right there to notify that that force is a vectors. Okay, even though right here we are talking about the scalar formulation. Okay, but in this diagram that force is drawn as a vectors right there. Okay, and then there is a we mentioned about the needs of the distance. Okay, and what is this distance? Okay, so this distance has to be the perpendicular distance, okay, between the reference point and the location where we apply the forces. Okay, and there is only one perpendicular distance from the reference point to the location where we apply the forces, and let's call that distance as d1. Okay, so in this case we can calculate that moment about point O due to the force F1 is equals to, okay, the force F1 multiply with that perpendicular distance d1. Okay, please note that right here I do not put any head anymore because we are just concerned about the magnitude, about the scalar quantities. So right here this is the magnitude. Okay, so it's a scalar, that's the magnitude of the force, and then that is the distance, so it's also scalar. Okay, that is this, to be more specific, that is the perpendicular distance, right? Perpendicular distance between point within the reference point O, okay, the reference point O to the location where the force is applied. Okay, and then with that, right, this is just multiplications right there. Okay, with that the moment that we obtains right there, that is also have a scalar quantities right there. Okay, so that is the moment of about point O due to the force F1. Okay, which is just simple multiplications of the force F1 to d1. Okay, and then let's observe, okay, another force. So that is F2. Okay, this F2 is the same as the F1 is going up vertically, however it's located at the right side of the reference point right now. Okay, and similar, there is a perpendicular distance between the reference point O to the locations where we apply that force, right? And in this case, we can write that moment about point O due to the force F2 is equals to F2 times D2. And please note that this is also called our scalar quantities as before. Okay, and right here, right, the next thing that I would like to discuss is about the sign convention, right? So what distinguishes between the moments right there and the moments right there that we calculate with respect to from point from the force F1 and force F2 right there. Okay, so in this case, right, so we have the force F1, okay, with respect to the reference point O right there, right? This force F1, if you try to kind of like draw a curve like a curve, like a surrounding the reference point right there from the directions of where the force is going, right? So you will try the curve that we draw is kind of like wrap around that point O in a clockwise manner, right? In the clockwise manner. Okay. On the other hand, right, on the other side over here, if we try to continue that force F2 and try to wrap around point O right there, right? So we are going to have this counterclockwise, right? So that's a counterclockwise counterclockwise rotations right there. Okay, and then for counterclockwise rotations, we will say that we are going to have a positive sign, okay, and then for the clockwise, we are going to have a negative sign. So clockwise negative, counterclockwise positive. Okay, so that in here, I think we need to start putting the sign that is negative right there, and then the moment about point O due to force F2 is positive right there. Okay, and then let's do another one down here. Let's say that I have force F3, right? So now F3 has certain directions, okay, going there, okay. Then there is this distance right here, okay, there is this distance right there, that is a D3, right? So maybe to be more consistent, I just use this as a yellow color right there, okay, so that does not confuse you. D1, okay. So that the distance is D3, and particularly that distance has to be perpendicular, right? The same thing as the others. Thus the distance has to be the perpendicular distance, okay, from the reference point to the forces, right? So in this case, we can write that MO, moment about point O, due to the force F3 is F3 multiply D3, right? And the sign, if we try to wrap around point O, right? This force trying to wrap around point O, then we find out that it also have a counterclockwise rotations, then it's basically positive sign, okay. And one last thing, okay, if we try to add up some of the moment at about point O due to all of these forces F1, F2, F3, so basically what we need to do is to add up those MO F1 plus MO F2 plus MO F3. But remember that we need to keep the sign conventions, meaning that F1 D1 right there should be plus of the F2 D2, and then plus the last one right there is F3 D3, okay, F3 D3, because both the moment about O due to the force F2 and F3, it has a positive sign convention. Okay, so later on in the example, when we have a more numerical value, then we can plug in to if we have the numerical value, then we can simply plug in to this expression in order to calculate the moments right there. Okay. One thing that I would like to emphasize over here is that there is no formula to memorize over here. Okay, so whatever we do right here is just trying to make sense. Okay, to figure out we have the forces, right? Then what is the perpendicular distance, right? And then after that, what is the sign convention? Okay, after we can figure that out, we'll deal with the calculations of a moment due to a set of forces. Okay, I think that's pretty much for these lectures. If you guys have any questions, okay, please don't hesitate to let me know. I'm more than happy to answer those. Okay, thank you.